Today we are going to do the third part of class 11th Newton's laws of motion. So first two parts we learned already is what about the types of forces. Then we completely freeze ourselves in class 11th about contact forces, so that we started. So first two forces we discussed already. First is what we discussed about normal force. What is normal force? Whenever there is a contact, there will be a normal force. Normal force will always be perpendicular to the contact surface. That is what we learned. And then even the blocks are like this, one block, two blocks, so we can say forces will be perpendicular. Let's so one is due to the ground on the block, and then block to block also there will be. Suppose the blocks are attached like this, so this block will apply force in this direction, and this block will apply force in this direction. So there also we can see the normal forces. Then we had done tension forces. Here is specifically in this topic we are not going to see the tension, string mass, pulley mass and all we are not going to consider. So tension force, we can say whenever there is a stretch on the string, like string, thread, all those things, whenever there will be a stretch, there will be a tension force. Tension force is going to act in upward direction, right? That we will see. Fine. After that we learned what about first law of motion. What is that? An object is at rest, wants to be at rest. An object is in motion, wants to be in motion, until and unless an external force is not applied on the object. What we conclude from here, being a student, one who wants to solve numericals, and anyway, nobody is going to ask you the definition of this. So you are supposed to understand from here is what? That object is in equilibrium. Object is in equilibrium in the sense is what? Upward force is equal to downward force, and left force is equal to right force. So in physics, anywhere the term comes like equilibrium, then directly what you are supposed to do is upward force, downward force equal, left force, right force equal. That's it. Being a teacher, again I am taking the advantage of being a teacher is what you are supposed to know to solve, like yet whatever we completed Newton's laws of motion, even vectors also. So few things which you are supposed to keep in mind whenever numerical comes, and if these points actually frequently will come in mechanics, especially. So whenever what is that point? First point is what? If any vector quantity is there, then we are supposed to find the net force of that. If any vector quantity is acting, more than two vector quantities are acting in an object or anywhere, then we are supposed to find net force of that, net momentum of that, net velocity, net displacement, net moment, net impulse, net electric field, net magnetic field. It means any vector quantity is acting more than two or three, then we are supposed to write the net of that. That's it. That is the clear cut thing is there. Second thing is what? Second thing we should know, if any vector quantity is acting at an angle of theta, then we are supposed to do component of that. That's it. If any vector quantity is acting at an angle of theta, then we are supposed to do component. Must remember this thing. If any vector quantity is acting at an angle of theta, then we are supposed to do component. Now you guys will say me like how to do component. Easy way. Most of the student will have doubt like how to do component. So easy way is what? This x-axis, y-axis, right? Net force is suppose acting in this direction, like this it is acting. Suppose the first angle is attached with x-axis. See, attached with x-axis, right? Angle is this I2. So if force, let's consider the vector quantity is here force, then you are supposed to do f cos theta in x-axis. Whenever theta is attached with x-axis, with any axis, if theta is attached with the axis, that axis is going to be cos theta. When theta is attached with any axis, that axis is going to be what? Cos theta, and opposite, like the other axis is going to be what? Sin theta. If theta is attached with y axis, then this is going to be cos theta, and this is going to be what? Sin theta. See, this all dots now like equilibrium, and then what? This vector quantity will be there, then we are supposed to find net force, and if vector quantity is acting, then we are supposed to do component. This all dots, if you will connect and you will remember properly, I will tell you further, if you will remember these points, then any numerical comes. The main thing is what in mechanics is, you are supposed to make the first thing, you are supposed to draw proper free body diagram. Second thing is what here, you are supposed to draw free body diagram. Second thing is you are supposed to know how to write equations. If you know these two things, no, you will not do mistake anyway. free body diagram, you know how to do component, you know how to write the equation. And writing equation, these things will help you. One more thing is there that I'll teach you and then I'll tell you. Fine. So basically in this class, that was like previous, this all dots you should know, so that to connect further more dots will come, that all you connect, really it will be easy for you guys to understand physics, that to mechanics now we are doing. Fine. Now let's see the main topic which we are going to do in today's class. We'll do numericals on that, we'll describe that properly, we'll see what are the pros and cons on that. That is second law. Second law is what we learned even before also in class 9. Net force is equal to ma. That is what we know, second law. Even now also we'll do net force is equal to ma. There is no change, but we should know how it came, where we will use, where we will not use. So those, all those things, and how to apply net force is equal to ma, that we are going to see. Fine. Net force is equal to what? Ma. That is the formula we are supposed to get from this. So here, magnitude of the force is directly proportional to rate of change of momentum. Magnitude of the force is directly proportional to rate of change of momentum. Whenever any force is acting on any object, the momentum of that object will change. Fine. Let's see. We will see the things like how it works, what is the formula, how it will come, that we'll see now. So in second law, we learned that net force, magnitude of the force is directly proportional to dp by dt. As you know, p is a momentum. P is what here? Momentum. Right? What is the formula? Mass into velocity, vector quantity, right? So let's remove this directly proportional with k. K is equal to what? 1. So F magnitude we can write mass. Okay, let's consider velocity is changing, so dv by dt. Guys, one thing we consider here, that mass is not changing, only velocity is changing. So when you are applying net, okay, I'll tell you later. So we can say now dv by dt is what? Rate of change of velocity with respect to time is what? We know acceleration. Acceleration is a vector quantity, so we can say ma. And again you should write here what? Net force. Most important point, never miss this point. If you'll miss this, finished. All right, net force you are supposed to write. Okay, what is the main thing here? M dv by dt means we can say m is constant here. To apply if net force is equal to ma, we understand one point here is what? Mass is constant. If mass is not constant, be a problem. Then we cannot apply this formula. So which formula we will apply if mass is not constant, right? So that we will see later. So net force is equal to ma. That is what we are understand. Net force means, again let's consider, suppose this object is there, one guy is applying 100 Newton of force in this direction, one guy is applying 50 Newton of force in this direction. Of course the block is going to move in this direction. If the block will displace in this direction, right? If this is going to displace with this extra 50 Newton in this direction, so ultimately what we did, common sense, the object is going to move in this direction. This is 100, this is 50. So net for how you will write? F1 minus of F2, 100 minus of 50 is equal to ma. So 50 is equal to ma. You'll get answer from that. That is what is net force. Hope so you guys understood. So always whenever in a object, if more than one force, one vector quantity in an object, if more than one vector quantity is acting, then you are supposed to find net of that. So here also we'll find net. Fine. Let's see, the main thing is what? Where we can't apply, like mass is constant, then net force is equal to ma. If mass is not constant, then we cannot apply net force is equal to ma. Generally they are not asking questions on like net force is equal to not ma, like some other formula will come in like some competitive exams. And then second is what? In assertion reason they will ask you these types of questions. So let's know properly what is that. So net force is equal to what? Ma. If it is not ma, then what will happen? So we can say now net force is equal to d, momentum is mass into velocity, right? Okay, let's consider vector quantity only. So we see guys, now we are going to do differentiation, product rule of differentiation, that we had done in basics math, in basics maths for physics, that we did in this physicsfire by Asad Alam. So that there you can see that what part 1, part 2, part 3, 3 parts I put there for basic maths. what is the use of integration, what is the use of differentiation, how we'll do basic integration and differentiation, as well as a little about log, properties of log, that we had done, and how we apply those things for it. So you can refer those videos also. So what we can say, if you want to do here, you'll have to apply product rule of differentiation. Okay, that I'm not going to explain here, but you can see the videos from there. So let's take m dv by dt plus v dm by dt. So that you guys can check from there is equal to what? Net force. That's it. Now here, if you will see, we are doing the differentiation of mass also. Before we had not done, because we consider mass is constant. Here mass is not constant. That's the difference, right? So we can say that whenever force is not like mass is not constant, then we'll have to use what? Differential equation of second law. So this equation also known as differential equation. Differential equation of second law. That's it. Differential equation of what? Second law of motion. So net force is equal to ma, m dv by dt, v dm by dt. That is what? Differential equation of what? Equation of second law of motion. Let's see the second thing. What we are supposed to conclude here is, if mass is not constant, where mass will not be constant? Mass will not be constant in rocket propulsion. You might have heard that when the rocket will go higher and higher, then what will happen? It will lose its extra masses, right? So mass is not constant there. And second condition where mass will lose, you might have learned E is equal to in notebook, right? Einstein photo with that E is equal to delta mc square, right? Energy mass equivalence equation that we say. Okay, that we are there we are not going. We are just focusing what? Delta mc square. What is this delta? Change in mass. Change in what? Mass. Losing mass defect also we can say. What we can say? This delta m, we can say what here? Delta m mass defect. Mass defect means ultimately we are losing mass. Remember, whenever any object is moving with the speed of light, or with the we can compare the speed of the object as the speed of light, then we cannot use, then we can then a mass then we will lose mass. Suppose 75% of the speed of light, 3 into 10 to the power 8 meter per second, right? So 30% even of that. So what will happen? It will lose masses. That's it. So there, one is what? Rocket propulsion. Second is what? Whenever the speed of whenever the object mass is comparable with the speed of light, then we can use these things. Then we cannot use net force is equal to ma. We'll have to use differential equation of second law. First, let's find. That's fine. Let's conclude like how numericals we will do here, guys. Three things are there that three things we should know properly. 99% cases, that is what net force is equal to ma will come. So we'll focus more on this. Net force is equal to what? Ma. So even before also I told you, whenever the object is in acceleration, if object is moving, the net force is equal to ma. That's it. If the object is in motion, if the object is moving, the net force is equal to what? Ma. Net force is what means what? More than one forces are acting, then you are supposed to find net force. Net force means towards the direction of acceleration. One more point came. Net force in the sense is what? What net force denotes? Net force denotes is what? Towards the direction of acceleration. You are supposed to consider the force here towards the direction of acceleration. Now see, one more point we can write from here. Suppose this object is here in this direction. If you are applying 100 Newton and this direction 50 Newton, then of course anyone can say with 50 Newton of force the object is going to move in this direction. It means acceleration is going to be in this direction, right? Acceleration is going to be in this direction. Let's consider one more example. 100 Newton of applied force, 30 Newton of frictional force. So we can say object is going to move in this direction with 70 Newton of force. It means acceleration of the object is going to be in this direction. Fine. So what you are supposed to understand from here, that any force which is acting towards the direction of acceleration, that force is going to be positive. Leave that. What you are supposed to know here, that any force which is acting towards the direction of acceleration, that force in net force is going to be positive. Means suppose this is F1, this is F2 and acceleration is in this direction, then this will be F1 minus of F2 is equal to ma. Got it? No. Let's see again. Suppose two forces are acting. One force is in this direction, one force is in this direction, F1, F2, and then acceleration is in this direction. Then what you will do? F1 minus of F2 is equal to ma. Any numerical comes where acceleration direction force will always be positive, opposite of that is going to be negative. Upward force is acting, downward force is acting, right? So we can say acceleration due to gravity is downward direction, right? If the object is coming down, then we can say acceleration is downward direction. And the so we can say this mg and tension. Suppose let's take this thing, right? Somebody so we can say if you'll pull this object down, so we can say mg is going to be downward direction, tension is going to be upward direction, and if you want to find here net force, and the like if it is connected with the pulley is having some acceleration, whatever, so we can say acceleration is downward direction. So we can say now mg minus of t is equal to ma. Remember one thing only, that acceleration direction will always be positive. Any force which is acting toward the direction of acceleration, that force is going to be positive. That's it. Let's write now. Let's conclude what we are concluding from this second law that we are writing. Conclusion. Conclude. What we concludes from here, net force is equal to what? Ma. And second thing is what? Force which is acting towards the direction of acceleration. Force which is acting toward the direction of acceleration, that will be positive. That will be what? Positive. Opposite of that is what? Negative. Net force, what you are supposed to conclude from here, net force is equal to ma. Net force you understood, right? And force which is acting toward the direction of acceleration, that will be what? Positive. Opposite of that is what? Negative. If you really connect these dots, no, any numericals will come. You will like easily get it. Fine. Let's try 1-2 numericals, then we'll see like how much we understood, right? Let's consider with basic sum we are going to do. Maybe sometime I explain the things many more times, but the thing is what, you are supposed to understand it properly. So I used to explain the things again and again, but that's fine. That we'll have to do. One force is acting in this direction, 10 Newton. One force is acting 15 Newton in this direction. Mass is, let's take 10 kg. Downward is acting, so obviously downward 10 g, right? Now they're asking find net force. Find net force and the direction of acceleration, and the direction of acceleration. So this, if you want to do the direction of acceleration as well as the net force, easy it is, right? What we are supposed to do, 10 Newton is lesser than 15 Newton, right? So we can say net force, guys, is going to be 15 Newton minus of what? 10 Newton. So it is going to be what? 5 Newton, right? So net force is equal to what? Ma. So 5 into what? 10. Find acceleration, not net force. Find acceleration and the direction of acceleration. So how much? 10 kg into what? A. So it is going to be this 1/2 meter per second square. In which direction? Obviously left direction, right? Not in right. Got everyone? So left. So by this way we can find let's see new some other. This is the easiest question, right? Fine, the first question was there, so we did little easy. Let's next question. Next question, if you're going to do here, we can make like n number of questions. Mass is m, force is acting F at an angle of theta. So now they are asking find acceleration, right? So find acceleration and normal of the body. N is what here? Normal force. Fine. We can say that force is acting at an angle of theta. So let's see how I'm connecting all the dots, whatever we learned. Okay, so being a student, what you are supposed to understand from here, that force is acting at an angle of theta. Fine. So whenever any vector quantity is acting at an angle of theta, then we are supposed to do component of that. That's it. So we can say this is going to be what? Any axis which is attached with theta, that is going to be what? Cos theta. That's it. Okay, then what? This is going to be what? F sin theta. Okay, downward is what, guys? Mg. Upward is what, guys? Normal. That's it. Okay, now we are supposed to find acceleration first. Acceleration is going to be what? Net force by m. Net force is how much here? First we are supposed to find acceleration. So acceleration is going to be only in horizontal. There will be no acceleration on vertical. So no need to consider that thing, right? So directly we can say here F cos theta by what? M. So that is acceleration. Yeah. So we can say net force is equal to what? Acceleration we found, and then they are asking to find the acceleration also, find the normal force also. Guys, up and down it is what? Equal. It is not moving. So it is in the first part is acceleration. There we did. There the object is moving, but in y-axis there is no movement. No movement means it is in equilibrium in y-axis, right? If it is in equilibrium, then upward force, downward forces, it is equal. So that also you'll have to consider, that if the object is not moving in any axis, maybe in a same object the object is moving in one axis, it is moving, in another axis it is not moving, because these types of questions will come, right? So we can say normal for upward force is what? Normal plus F sin theta is equal to what? Mg. So normal is equal to Mg minus of what? F sin theta. That is going to be the normal force. That's it.